Hey, it's Mr. Engstrom here. We're going to do a little review. Let's take a look at this dot plot. It is of quiz scores, and we can see that it is symmetric, which means that the mean is equal to the median. Now, this one is perfectly symmetrical, which most of the time that doesn't happen. So when you're describing data as symmetric, a lot of times you're going to use the word roughly. It's roughly symmetric. Here we have an exact thing going on, okay? But what if I take a couple of the low scores and replace them with even lower scores? What happens? First, you got to know if this is called skewed right or skewed left, because sometimes I have students flip-flopping those. But if we take a look at what it would look like if this was symmetric, roughly symmetric, it would be something like this, okay, roughly. But that's not exactly what's happening here. So take a look at what we did. We grabbed this tail and we pull it to the left. And so that's what we call left. Okay, that was weird. Left skewed. Okay, so when that happens, notice what happens up here. You see, when we pulled the tail to the left, what we did is we took out some low ones and put in something even lower. The middle number, the median, stayed the same. That was this 7 right here. That stayed the same. We didn't mess with the middle number, the median. But by taking out some low scores and putting in something lower, the average, the mean, is lowered. So when we have left skewed data, here's what's happening. We know that the mean has been pulled to the left, so it is less than the median. The mean is less than the median when we have left skewed data. Here's an example of right skewed data. Okay. Again, we're going to take a look at the shape, what it would look like if it was to be symmetric, roughly symmetric, something like that. But then we take that tail on the right and we grab a hold of that and we stretch it to the right. So we call this is right skewed data. And what happens when we have right skewed data, and you can see that right here, the median doesn't change. That's not affected. What is affected is the median, the average. So when we have right skewed data, we know that the mean is greater than the median. The mean is greater than the median when we have right skewed data. Okay, so that's something you got to memorize. Here we have a box plot. This is test scores. So let's go through what each of these things mean. Okay. Well, this right here, that is the minimum value. This one right here is the maximum value. So one thing we can get out of that is, of course, the range. Remember, the range is a number. We don't say that the range is from 50 to 90. We say that the range is the maximum minus the minimum. The range is 40. Okay, so keep that in mind. Range is 40. Now let's take a look at what some of these other things mean. This thing right here is the median. The median, it's the middle number. It looks like that's about 75. That median, sometimes we call that Q2, the second quartile. Okay, the second quartile. That's the median. The median is 75. Of course, that splits our data into halves. So in context, that means that half of the students, well, we usually say about half of the students score from 75 to 90. And there's a reason why we say about. We'll get to that later. But 75 to 90. About. Well, the reason is because 75 might be a data value. It actually might not be. Maybe the two middle data values are 74 and 76, and so we say the median is 75. But that's why we usually say approximately. But approximately half of our students scored between 75 and 90. That's the upper half. The lower half scored between 50 and 75. So let's take a look at our other numbers here. This thing right here, 60, that is the lower quartile. Sometimes we call that Q1, the lower quartile. Lower quartile. Well, it sounds like what it should. It's quarter, right? So between 50 and 60, that's our lower 25%. So 25% of the students scored below 60, more specifically between 50 and 60. Well, then that makes this, and remember the median is Q2, that makes this Q3, which is the third quartile, or we'll call that, I'm not sure why I was scribbling there, upper quartile. So the lower quartile was 60 and the upper quartile is 80. Of course, what that means is the top 25% of our students scored between 80 and 90. Another thing you need to know is the interquartile range. That's the range of the middle half. So if you look at this this box here, that box represents your middle half of data. Okay, so the interquartile range is the range of the middle half. In other words, it's Q3, the third quartile, the upper quartile, minus the lower quartile, Q1. So in this case, that's 80 minus 60, and so that equals 20. Okay, and make sure everything is always in context. So if it asks for the interquartile range, make sure you see that these are the number of test scores. Okay, so the middle half had a range of 20%, because I see that this goes up to 100. So those are probably percent test scores here. Okay, the last thing that I want to talk about briefly is standard deviation. To deviate means to come away from. If we're deviating from our plan, we're coming away from our plan. So we're dealing with a bunch of numbers, data, okay, dealing with lots of data. So the deviation is the distance that each data point deviates from the mean. And because we're looking at roughly symmetric distributions here of the center, we're looking at the mean. And so standard deviation describes the typical distance that the data value is away from the mean. In other words, it talks about how spread out the data are. So when we look at these three graphs, this one here, right, I was going to circle it. There we go. That one has the smallest standard deviation of the three, because we see that it's not spread out from the mean. Looks like the mean is about 100, and they don't look very spread out. But if you look at this one, it's more spread out from the mean. So this is the data set that has the biggest standard deviation. This is the data set that has the smallest, and that one is somewhere in between. So if we take a look at the real standard deviations, that's what they are here. So the one over here on the right, that has a standard deviation of 31.6, which is quite a bit bigger than that. Okay, so the bigger the standard deviation, the more spread out the data are from the mean. Okay, more spread out from the mean. All right, that is the end of our review. Have a great day. I will see you tomorrow.